Thank you, everybody. So today we're going to be talking about APIs and how we can hunt for API vulnerabilities, and obviously how we can make money in the side by hunting and reporting APIs. So if you've noticed before, we have Integrity outside, so they have lots of API assets. So basically, if you can find vulnerabilities in APIs and report them to platforms, you can probably make money on the side alongside your regular job. So that's what the presentation is going to be all about. So I'm Nithin, and I also go by the handle at the binary bot in most of the places online. I am currently a student in University of Galway, so this is my home ground, and I'm doing my master's in information systems management. I also worked as a solutions engineer back in India. We did a lot of deception tech, security services, etc. It was a security startup that I worked on. I am also a dev, but besides a dev, I'm an absolute security nerd. I believe that you have to build something to break it, so that's why I do sort of like with the things. I hold EJPT and CRTP. EJPT is the junior penetration tester. CRTP is the red team professional. I also love to create content occasionally, but I'm not very consistent. But regardless of all this, if you want to find more information about me, you can head to my portfolio. It's thebotside.com. So with that being the agenda for today's session is going to be like this. We'll be talking about APIs, what they are, the classification, the types, and the nuances of different APIs, and obviously why hack APIs at first place, what's the difference between hacking an actual web application versus hacking API endpoints. I'll also be talking about different API reconnaissance techniques, passive reconnaissance techniques, active reconnaissance techniques. We'll also be diving into authorization vulnerabilities, more specifically on BOLA and BFLA, what they are, what are the different ways you can test for these vulnerabilities. And obviously, I have certain generic tips that I would want to share with you. These tips, they have helped me in lots. I used to do a lot of bug bounty and all of these stuff. So these are things that I have practically gained through experience. And they're absolutely good. One of the things that I really love about APIs is how creative it is. It's not, you can't probably put a certain roadmap of sorts and then go through a step-by-step process. It's not really like that. It's really creative. So I hope you really learn something that's absolutely cool throughout this presentation. So to start with, what is an API? Now, I absolutely refrain from giving any technical jargon. I don't want to throw anything like that. I tend to keep my presentations as simple and as analogous as possible. So you can think of an API as a middleware that's connecting to different software applications. So API by itself stands for Application Programming Interface. But if you use this analogy that's shown on screen here, you can think of the API as a waiter. For example, let's say you're going to a restaurant and then you want to order food. You're not going to go directly talk to the chef and say, hey, I want sushi, or hey, I want a fish and sticks, or whatever it is. There's a waiter that's going to come to you. You're going to place the order to him. He's going to get the information passed to the chef, and then he's going to bring the food to your table. That's how it works. That's basically how an API also integrates to different software applications. So, let's say the customer is software application 1 and the chef is software application 2. If there needs to be a communication transfer between these two applications, you have an API that's sitting in between. So basically what the API does is it basically receives a request, it collects, and then it processes a response, then returns with that particular response for the request that you've sent. So that's basically the flow of an API. When you probably go to Google and then if you search for classifications of APIs or types of APIs, you're probably not going to get the picture on the second that you see here. There are different types of APIs per se. These are generally called as types of APIs. You have private APIs, partner APIs, and open APIs, but I like to call them as classifications because types of APIs can be very different. I generally like to call the types of APIs from an architectural pattern and not from a base, how it's defined sort of a pattern. So talking about classifications of APIs, we have 3 different classifications. One is private, we have partner, and then we have open APIs. So all the things, for example, if you go to platforms like Rapid7 or Rapid APIs and anything that you can, like I built a cool application a couple of days back, and then I used this API called as MeowFax API. Basically, the endpoint basically gives you all cat codes, and then you can collect them, process them, and then put them in your application wherever you want it. So all of these things are open APIs. You don't have it's basically out in the wild for everybody to use, everybody to access, etc. But let's say you're an organization and you have a lot of different partners that's working with you, and then you want to only share certain restricted data with them. That's probably not safe to share with the open world. You have these partner APIs. For example, it can be something that's related to something that's got to do with the financial data of your client that you're working on, or anything that only you can share with the partner. So those endpoints fall under the partner APIs bracket. And then we have private APIs. Now, private APIs are really cool because these are intended to be used only by the devs of that particular organization. You're not going to share this out with everybody else in the wild. And it's pretty hard to get access into private APIs, but partner APIs are really cool area to target. I don't think a lot of people target on partner APIs, but it's an absolutely cool, interesting venue for anybody to hack on. With that being said, there are two different types of APIs. Now, again, I call them as types of APIs from an architectural pattern or architectural structure field of view. So we have REST APIs, and then we have GraphQL APIs. REST APIs, I think most of you would be familiar with this. You use the regular HTTP methods to access data. You have get, put, post options, etc. And the kind of the kind of response you get from a REST API is either JSON or plain text. One of the cool things with REST APIs is you have a defined structure or a pattern through which the request is being sent and through which the response is being sent. I'd also talk about why that's really cool in the upcoming slides. But GraphQL is pretty, I would say it's really different in terms of just looking at the request. I haven't hunt much on GraphQL endpoints. It's really, but it's a definitely interesting area to approach. One of the speakers, Botkin, is going to talk about GraphQL APIs soon. So, definitely urge all of you to check with that. But, again, with GraphQL API endpoints, you have a single request, not multiple requests, which often gives you different sets of data. That's the, if you look at a bigger perspective, that's the difference between GraphQL and REST APIs. In REST APIs, you have multiple endpoints giving you multiple sources of data, but then in GraphQL, it's going to be one single endpoint, and then based upon the query you give, it's going to give you different types of data. Now, coming into the main picture, why hack APIs at all? Now, if you've looked at the recent statistics of API calls in the last couple of, I would say years, you have about 80% of the data that's going in through the internet as API calls. So you can look at this issue that was posted in 2019, which says that 83% of the web traffic is API. And then we have a lot of cyber criminals that's also actively targeting API endpoints. And people don't generally hack on API endpoints. I mean, people as in, I'm talking about the white hat industry, people who are hack for the good. They don't really target API endpoints because you don't have like a GUI, you don't have like a web interface of sorts where you can, probably go click buttons and then it's going to give you some data and burp, which you can tamper and then hunt. It's not going to work that way. It's very intuitive. It's very different. You're going to do a lot of recon and you're going to do a lot of CLI activities, which may not be very intuitive at first place. But if you think about it, in the backside, it's really cool and it's really interesting. So again, one of the reasons why I think almost everybody in this room should go and hack APIs is because almost a huge population of the web traffic is being controlled by APIs. And if you can help secure the API endpoints, then you are eventually making the digital space safe. So that is why I think everybody should hack APIs. Now moving into the main idea, API recon. Recon basically is finding any data that can help you to sort of get you more data from that request that you're hunting on. Now, so you can pretty much find there are like different techniques for you to perform reconnaissance. From an absolutely no standpoint, you can look for API endpoints from API documentation. You can go and look out for keywords like API, Swagger, OpenAPI. You can type all of these words. For example, let's say you're hunting on, say, integrity. You can go integrity in title API, or you can do integrity plus API. There are different Google docking techniques. You can check out them. But basically, if you append the words like API, Swagger, OpenAPI in Google or any other search engine, you're probably going to get a lot of API endpoints, which you can collect. And then I really like to use, whenever I'm hunting, I absolutely love to use a notebook of sorts, like a virtual notebook. I use Obsidian, and then I collect all of these endpoints and then put them all separately. What I also love to do is I love to monitor all of the URLs while browsing. So, for example, let's say you have a web application that you're hunting on. You're obviously going to proxy this request with, let's say, Burp, or you have Kaido recently that's come up, or you have Zap if you prefer the free version. And then you're going to collect all of these requests and probably going to save all of them in one single place. But again, with APIs, you're going to have lots of interesting subdomains, lots of interesting endpoints. So what endpoint should I obviously target first? That's a question that I've received by lots in the past. One of the things that I really recommend people check out is subdomains that's starting with UAT, def, test, because these are areas that, again, has a plethora of information, and they're just interesting. The kind of information they reveal is very interesting, and if you report them, you're going to eventually get a really good payout. Now, as we talked about reconnaissance, from a body perspective, we have active recon and then we have passive recon. What passive recon does is it doesn't allow you to hit the target endpoints by themselves. You're going to find more information about the target by any information that's available out in the wild without hitting the target by itself. So you can go to Google, you can go to GitHub, you can go to Shodan, you can go to Bing. You can probably find information from any search engine, or you can also use tools like FOFA. You can also use tools like WebArchive. Any engine that can give you data about a target without you practically going and hitting the data itself falls under the category of passive reconnaissance. A couple of interesting things that I love to do with Google is, for example, let's say I have a target. Let's say I am hunting integrity for today. I would go and then type integrity space API first, and then I would go do in URL WP-JSON WP2v2 user. So what that does is it finds, so if you look at WordPress endpoints, they have this endpoint called as WP-JSON. And that endpoint is absolutely cool. They have, again, I don't really know how to specify that with an example. I'm really sorry about that. But if you go to that particular endpoint, you're going to get lots of interesting data. So that's an area that you definitely want to check out. You can also look out for specific API versions. So, for example, let's say that you found API v1. For example, let's say you're hunting on integrity and then you find API docs termed as API v1 integrity. Don't just stop at API v1 integrity. Go on and probe for more API versions. Probably they have v1.1, v1.0.1, v2.1. And one of the things that I really love to do is, for example, let's say you found API v2.1. Don't just look what's ahead. Always look what's come before, because those API docs are going to have lots of endpoints that were probably, let's say, deleted because they had some sort of sensitive data. So what I generally like to do is go on and go hunt for the previous versions of API endpoints, which is really interesting. You can also doc for interesting endpoints from GitHub. So always look out for extensions like JSON, because they obviously have some sort of API endpoints, I believe. And you can also look out for files like Swagger.json, a really cool place. You can also do the same kind of talking on Shodan. One of the things that's really cool with Shodan is you can filter with respect to content types. So if you have content types as application/station or application/XML, you're obviously going to, again, find a lot of interesting API endpoints. So that's with respect to passive reconnaissance, but when it comes to active reconnaissance, this is where things get really interesting again. You can use different tools like Amass, GoBuster, Kite-Runner. One of the things that I really love to do with Amass is pretty slow compared to other tools, but it again does a lot of checks. So you can technically, let's say you have an API word list. I always love to, create an API word list whenever I'm hunting on applications, and then I maintain that word list like it's like one gigantic platform or repository of endpoints, and I'm going to test that with almost every single target that I'm hunting on. I call it the API brute word list, and then I use that with Amass for every single target that I'm hunting on using the command that you can see here. If you don't want to do brute force, you can also use Kite-Runner's quick scan. So Kite-Runner is, again, I don't think a lot of people use Kite-Runner recently. It's a tool that's developed by AssetNode. It's really interesting because Kite-Runner has this unique engine which sort of recurrently checks for other API endpoints. So for example, let's say you have API v1 user. It doesn't stop at API v1 user. It's going to go and probe and check if API v1 admins available, or if API user, API v2 user is available, or if API v1 user / particular usernames available, etc., etc. So it does all of these repetitive checks, which makes it really, really interesting. And one of the things with active recon is if you see the server that's responding uniquely to requests, for example, to certain API paths, always collect those information, because that's like that basically gives you that an API endpoint exists there. So make sure that one of the things that I really like to do is always collect all of these endpoints and just keep collecting them. Note taking is absolutely wonderful here. Moving on to vulnerabilities by themselves. There are two specific vulnerabilities when it comes, which is really interesting when we're talking about APIs, and they are both authorization vulnerabilities. Authorization, by definition, stands for let's say you hit an endpoint which you don't have access to initially, but let's say you do some sort of tweaks or you apply certain quirks to that endpoint, and then if you are able to get some data from that endpoint which you're not able to, which you shouldn't be able to access at first place, then you have an authorization vulnerability. Again, there are two different types of authorization vulnerabilities. We have BOLA, which stands for Broken Object Level Authorization, and then we have BFLA, which stands for Broken Function Level Authorization. Now, one of the ways in BOLA works is, let me directly skip to the next slide. You can find BOLAs in different endpoints. For example, let's say you have a GET request as API resource 1. Whenever you see IDs or whenever you see any entity that's referring to a group or an organization, you probably might find a BOLA there. So if you, let's say, see requests like API resource 1, if you see requests like post admin password reset account 90, you can go and tweak these IDs. So for example, let's say your ID is user ID 90 and you are trying to reset your password. I'm talking about the last example here. Think of other ways. Can you probably do admin password reset account 91? Can you do 89? Can you predict the IDs of other people, and can you try to reset the password on their behalf? So these are, again, really creative ways you can think about. So whenever you find all of these IDs, try to tamper them, try to basically give any ID that shouldn't exist there and see what sort of response you're getting back. And eventually, if you hit an ID that doesn't belong to you, you're probably going to have a BOLA there. The testing strategy for BOLA is pretty naive. It's pretty straightforward. What I generally love to do is create an account, use the API and discover any resource that maps to user A, document all of the resources that maps, create another account user B, and then you have that user's token, you have user A's request, copy user's B's token, and then place it in user A, check if you get the data back. If you do, you have BOLA. That's a very simple testing strategy. You can, if you're using WebSuite, there are different plugins like authorize, all of these that you can use, and they make it really cool. It's really easy. Couple of testing mechanisms. Whenever you have API endpoints like, let's say, get API v1 user 222, you can tamper that request and look for other IDs. You can, couple of other quicks that I always love to do is, let's say you pass an integer by itself, try to pass the integer as an ID. For example, place it as in a block of IDs. If you have account 222, try to place account 333 within blocks, try to nest it, try to include multiple objects. So these are various techniques that you can use to basically just check how the API is responding to you. Based upon that, you can further tweak your request like that. One of the other things that I haven't mentioned here, I found a really cool bug recently. The way I found it was I had a similar endpoint. I had API v something user that returned a 403 to me. So I placed a wildcard after that. I didn't have an ID, but then I did API v1 user /star, which returned data for all users, and that was a massive PII. That was a really cool find. It was a critical, and so you can. It's basically as creative as you get. You're going to find lots of interesting vulnerabilities. So that's with BOLA, and BFLA stands for Broken Function Level Authorization. Now, the difference between BOLA and BFLA is in BOLA, you're only looking for post and put data. You're not actually trying to modify data by itself. But let's say you have the ability to delete another person's ID or delete another, basically perform any CRUD-based method on another person, then you've eventually found BFLA. The testing pattern's pretty much the same. But for BOLA, you do A/B testing. For BFLA, you do ABA testing. Basically, in ABA testing, what you do is you not only go modify the resources, but you also go back with the same user account A, and then you check if that data has been modified or not. So pretty much the other things are the same, except that you play with methods when you're doing BFLA, and you play with IDs when you're doing BOLA. A couple of other miscellaneous bugs you can also look out for injection attacks. So again, think of the most absurd cases that you can find. For example, if you have IDs, think about what would happen if you give a 0 there, what would happen if you give a negative number there, what would happen if you don't give a number at all, and then try to look at the responses. There's definitely going to be a difference in response. Always do a diff between the responses and try to find out how it's processing all of these different queries. You can also do mass assignment attacks. This is again really cool. While I was hunting at one of other one other programs, I found this parameter called a sysadmin, and it was not assigned to that particular request, but I just tried to use it, and then I set it to true, and then it gave me admin access. So that's again a really cool find. So you can do things like that. You can also use server-side parameter pollution. Again, basically what this means is inject different parameters in the URL and try to look at how the response is being for you. Couple of other tips before I close off. You can always do version checks. For example, one of the things, like I talked about, one of the things that I really love to do is look out for specific versions. So let's say if you have API v2 register, check if API v1 exists. A tip, again, like one of the ways you can probably also find previous versions is copy that request, copy that URL, go paste that URL in Web Archive, or look out for the previous versions of that endpoint, and you're probably going to find previous versions of that particular API, which is going to give you more details. So utilize platforms like FOFA, Web Archive. They're all really interesting. And let's say if you've got an SSRF, don't stop there. Always look for possibilities for you to chain the vulnerability. If you've got an SSRF, think about how you can use that particular endpoint, and then probably leverage cloud services or any internal applications that you have. So all of these would not only give you a medium vulnerability, but if you're able to probe further and access any company-specific data, you're eventually going to find a critical. Think of different ways in which you can authenticate APIs. If you have API v3, you're think whether you have API mobile, you have can you authenticate yourself via some sort of magic links, etc. So again, all of these things are bound to creativity. So as creative as you can get, you're going to find more endpoints. I think that's that with me. I have written a guide on API hacking specifically. If you want that, you can check that out here. I obviously link the contents out somewhere in my socials. But if you want to find me in socials, these are ways in which you can connect with me. I think I'm done, but if you have any questions at all, please feel free to shout out. I'd be happy to answer them.